SAPHIRA proposes the development and implementation of innovative smart and antimicrobial packaging systems and nano-edible coatings based on agri-food waste derived materials. The final aim is to reduce post-harvest losses of perishable Mediterranean commodities, mainly fruits, preventing their degradation and extending shelf life through an integrated and multidisciplinary approach of the entire value chain. SAPHIRA results will help increase the supply chain's sustainability, giving added value to current byproducts obtained from primary agricultural production. A life cycle assessment, LCA analysis, will be performed in order to estimate the potential environmental impact and economic feasibility of the new systems with respect to their traditional counterparts. The supply of food products with monitoring systems in order to guarantee their safety and quality on the basis of international standards is a great challenge that SAPHIRA will face through the development of biosensors for the detection of pathogens. The multi-actor approach of the present proposal will promote the cooperation among different stakeholders working along the supply chain, furnishing eco-sustainable and low-cost innovations to farmers, decision-makers, academics, and economic enterprises. SAPHIRA presents a highly multidisciplinary character involving several key areas of research: food nanotechnology, innovative biomaterials, advanced sensors, ICT traceability, new market models, and innovative training and dissemination plans. SAPHIRA project is aiming to solve two relevant social and health concerns: the urgent need for new, efficient solutions for food packaging in order to increase food shelf life and safety, and the emergency for a sustainable waste management in agreement with the Zero Waste Standard and the circular economy strategies. In details, SAPHIRA systems will be based on bio-based compostable polymers and agri-food waste-derived extracts and fillers to provide antimicrobial and antioxidant properties and mechanical reinforcement, respectively. In this manner, antimicrobial chemical compounds will be replaced by natural agents, while natural fillers will be used to provide a completely eco-sustainable approach.